Good morning. Today we are doing 4B, which is quadratic in form. Now, certain equations that are not quadratic equations can be expressed in quadratic form by making suitable substitutions. The key to recognizing equations that are quadratic in form is that when the equation is written in standard form, so let's take a look at this one here. We need to write it in standard form first. So I'll have a 4x to the fourth plus 7x squared minus 2 equals 0. So standard form, it is descending values on those exponents there equaling 0. The exponent on one variable is half the exponent on the other variable. So what I do when I do these types of problems, I always look at whatever this middle one is right here. So that's an x squared. So I take that square, and if I multiply it by 2, I get 4. And if 4 is that one, then this is quadratic in form. Now it is not quadratic because quadratics, the highest power is a square. So this is quadratic in form. So the first thing we're going to do here is substitute in u for our middle term, okay, or the variable of our middle term here. And I always do it for the middle one. So my u in this case, and you can use whatever you want, just that we usually use u. Okay, so u is going to be x squared. Well, if I look over here, isn't x squared squared, isn't that x to the fourth? Okay, so when I substitute u in, this is going to be 4u squared plus 7u minus 2 equals 0. Because remember, x to the fourth is x squared squared. So we would put our u right here because u is x squared, and then we'd be squaring it. And this one's an x squared, so it becomes the u. Okay, so the next thing we would do is we're going to solve it for u. So we're going to take this here and we're going to solve it. You can do any way you want to solve it. You can factor it. This could be factored fairly easily. You could use the square root property. I would not use it because you have a middle term here. You could use the quadratic formula. You could use completing the square. I wouldn't try that. That would be just ugly. So your best bets on this one here are to factor it or the quadratic formula. Either one. Okay, so I did factor it and I got 4u minus 1 times u plus 2 equals 0. Okay, now I am going to use the zero factor property. When I do that, I will get u equals 1/4 and u equals -2. Okay, so we solved it for u. And now what we're going to do is substitute back in because we have x's in our original, so we have to substitute back in. So every time I see that u, it's going to become an x squared. X squared equals 1/4, and an x squared equals a -2. Okay, so now we substituted that back in, and we're going to solve it for x. I want x, not x squared. So I'm going to take the square root of both sides, and that's going to give me x equals plus or minus, well, square root of 1 is 1, square root of 4 is 2. So plus or minus 1/2. Then over here, take square root of both sides, and I'll get x equals plus or minus I square root of 2. Okay, so that's what we're going to do. We're going to substitute in u for that middle term. We're going to solve it for u, and then we're going to go back and substitute the x back in and solve for x. All right, this next one here is a bear of a problem, okay? Because we're solving for all of our x's, not just the real x's. So this one actually turns out to be sort of hard. But let's see if it qualifies. Is it quadratic in form? So it's in standard form. I'm looking at this middle one here. This middle one multiplied by 2 gives me the 6. So yes, it is quadratic in form. So my u is going to be whatever that middle one is. So the middle one is an x cubed. Okay. So this really is x cubed squared. All right. So I am going to put that in there, and I will have u squared minus 9u plus 8 equals 0. Okay, I can factor that easy enough and get u minus 8, u minus 1 equals 0. I'll have u equals 8. U equals 1 using the zero factor property. Oops. Okay. And then let's substitute that back in. So again, x cubed equals 8 and x cubed equals 1. Well, these look really good. I mean, you'd think, okay, I can take the cube root of both sides and be done with it. But you need to remember that formula that goes, let's see. Well, let's move that over first. Let's go x cubed minus 8 equals 0 and x cubed minus 1 equals 0. Remember the formula goes a cubed minus b cubed equals a minus b times a squared plus ab, oops, running out of room, plus the b squared. Remember that formula? We're going to need that here. Because if I just took the cube root up here, that's going to give me my real answers, but there are more solutions, okay? So I need to identify my A in this case, which is going to be x, and my B is going to be 2. It's like, what did I cube to get this? What did I cube to get this? Then I'm going to plug it into my formula over here, and I'm going to say, okay, that is x minus 2 times square the x, so x squared. Now I have a, b, so multiply them together, plus 2x. Then I have my b squared plus 4 equals 0. Okay, so if I use my zero factor property on this one right here, I get a 2. Okay, there's my answer number 1. And there can be 6 of them, right? Okay, so now let's take a look at this one. Now remember, we couldn't factor this because it needed that 2 in there. So to actually be able to solve this part of it, we need the quadratic formula. So remember that one goes x equals negative b plus or minus square root b squared minus the 4ac all over 2a. All right, so in this case, my a is 1, my b is 2, and my c is 4. I substitute it in there. So x equals the opposite, plus or minus, square it. This gives me 4 times that negative 4, so that's going to be negative 16, 2a, so over 2. Okay. Now, let's see here. Let's clean it up a little bit. Look at -2 plus or minus square root -12 over 2. Now, 12 really is 4 times 3. Okay, so now I have -2 plus or minus 2i. Sorry, I should have 2i square root of 3 over 2. I have lots of 2's in here, so I'm going to factor out a 2 up here, and I'll get -1 plus or minus I square root of 3 over 2, and those guys here cancel out. So because I have that plus or minus, this is 2 answers. So this is number 2 and number 3, okay, for my answers right there. Okay, so halfway there, we still have to deal with this one right here. So x minus 3, identify your a and b. A equals x, my b equals 1. We're going to plug them into this formula up here. I will have an x minus 1 times x squared plus x plus 1 equaling 0. Okay, when I do this one with the zero factor property, that's going to give us x equals 1, and that is number 4. Okay, so that is our 4th answer. Still need to go on this one here. Again, we're going to have to use our quadratic formula up here. So let's identify our a, b, and c. A is 1, b is 1, c is 1. Okay, let's plug them in here. So x equals -1 plus or minus 1. That's 1 times the -4, so -4 there over 2. Okay, so that gives me x equals -1 plus or minus square root of -3 over 2. Oh, and that -3, that I can come out. So x equals -1 plus or minus I square root of 3 over 2. And that is number 5 and 6 right there. Okay, so there are all of our answers on that one. I will not make you do this one on the test or even in your homework, but I wanted you to see how it was done just in case it pops up in Math 111. All right, the next one here, is this one quadratic in form? So it's in standard form. Let's take a look at this. So if I have 1/3 times 2, that gives me 2/3. Oh, and that's a 2/3. So yes, this is quadratic in form. So I'm going to say u equals x to the 1/3. Remember, always go with that 1 right here. Okay, so I'll get 5u squared plus 11u plus 2 equals 0. Okay, now again, you get to solve this any way you want to. You can use factoring, which is what I'm going to do here. You could use square root property because you have a middle term, so I wouldn't do it. Anytime you have that middle term, just walk away from the square root property. You have completing the square. Again, I would not use that because you have a leading coefficient and you have an odd number right here, so that's going to turn out really messy. Or you could use the quadratic formula. You know, that works on everything. So do whatever you're going to do. I am going to factor it. I'm going to get it to be 5u plus 1 times u plus 2 equals 0. Okay, now we're going to solve for u. So using the zero factor property, I'll get u equals a -1/5 and u equals -2. we're going to substitute back in. So x to the 1/3 equals -1/5. And x to the 1/3 equals -2. Well, we want x. We don't want x to the 1/3. So what I have to do here is raise this to the 3rd power. And if I do that on that side, I have to do it on this side. So let's take a look at that. Power raised to a power, you're going to multiply straight across. That's going to give me 3/3, which is a 1. Okay, so that does work. So this will be x equals, okay, you cube the negative, it's going to be a negative. Cube the 1, it's a 1. Cube the 5, you're going to get 125. Okay, same thing over here. Okay, we need to raise both sides to the 3rd power. This is going to give me an x equals, cube the negative, you're going to get a negative. Cube the 2, you're going to be an 8. And there you go. That's it. Okay. Next one. Okay, so here, if I had, this is in radical form. If I were to switch that over to exponential form, that would be x to the 1/2. Remember, your index becomes your denominator down there. Okay, so if I take that x to the 1/2, well, the 1/2 there, and I multiply that by 2, that is going to give me a 1, right? Well, isn't that x? There's an implied 1 right up there. So this is going to work here. So my u is going to be square root of x. All right. This is going to be u squared minus 3u minus 10 equals 0. All right, factor it any way you want. Okay, so we got that there, and then equals 0. Solve for u, 0 factor property, u equals 5, u equals -2. All right, now we're substituting this one back in, okay? So square root of x equals 5, square root of x, oh, I was on the right track. Square root of x equals -2. Okay, so I want x, not square root of x. So I'm going to square this, and I'm going to square this. That gives me x, because when you square something you're taking a square root of, that will come out, equals 25. Then over here, can a principal square root equal a negative number? No. So that one does not exist. So this one would be our answer here, okay? Because this one doesn't work over here. And since you actually were squaring, you should probably check your answer to see if that works. 25 minus 3 times the square root of 25, which is 5, right? So that's going to be a 15, just say 15, then minus 10. So if I have 25 minus the 15, that gives me a 10. 10 minus the 10, that's going to give me the 0. So that one works. Now, if you tried this one, it's not going to work. Okay, next one here is this quadratic in form. Take that -1, multiply it by 2, and I get a -2. And I have a -2 over there, so that works. So u is going to be x to the -1. Okay, so 10u squared plus 7u plus 1 equals 0. All right, now you are going to factor it any way you want. Again, I would not use the square root property since you have this. I wouldn't use the completing the square because you have an odd number right there. And I am going to factor this, okay? And when I factor it, it is going to turn out to be 5u plus 1 and 2u plus 1 equals 0. Okay, so let's solve it using the zero factor property. That'll be u equals a negative 1/5 and u equals a negative 1/2. Okay, substitute back in. So x to the negative 1 equals negative 1/5. X to the negative 1 equals a negative 1/2. Okay, so I want x to the first power, not the negative first power. So to get that to be positive, I'm going to multiply that by x to the negative 1. Okay, power raised to a power, negative 1 times negative 1 is going to give me a positive 1. Okay, now if I do that there, I have to raise this to the negative 1 as well. Now remember, when you are raising something to a negative exponent like that, flip it. Okay, so if I flip that, it becomes negative 5/1. And as soon as I flip it, it changes that sign. Now this has no effect whatsoever on that negative sign. Okay, and what is 5 to the first power? It's 5. What's 1 to the first power? 1. So, and then you still have that negative there. So this one is negative 5. Over here, let's do the same thing. Okay, so negative 1, both sides we're raising to the negative 1. So that's going to give me an x equals. We're going to flip it, and we still have that sign, so negative 2. So those would be my two answers, negative 5 and negative 2. Okay, this one, next one here, actually is quadratic, but we can use this principle to make the problem actually a lot easier. Notice I have an x plus 3 squared and an x plus 3. Okay, so if this right here is to the first power, I multiply it by 2 and I get that one over there. We can use this. Okay, so normally, you know, you could expand this, distribute and distribute, then combine everything and then do the problem, but it's so much easier to do it this way. Okay, so u in this case is going to be x plus 3. So u squared minus 2u minus 8 equals 0. Okay, factor. Minus 4 plus 2 equals 0. Use the zero factor property. So u is going to be 4, u is going to be negative 2. Okay, let's substitute that back in. So now I have x plus 3 equals 4 and x plus 3 equals negative 2. Solve for x. So let's move that over. I'll get x equals 1. Move this one over and I'll have x equals negative 5. And there you go. That's all there is to it. Okay, hope you enjoyed. See you next time.